right, first of all, we need to draw the drawing for number 4. Number 3, 4, 5, and 6 are dealing with this. They tell us that triangle ABC is congruent to triangle DEF. Okay, so let's draw those. So I have a small right triangle. All right, and this is my ABC. All right, this is 4 centimeters, 5 centimeters, and 3 centimeters. All right, then they reverse this. Now that first triangle, they don't tell me that it's a right triangle. What does a right triangle mean? For a triangle to be a right triangle, what does that mean? What does that mean, Cameron? It has a 90-degree angle. How do I know if a triangle, like if you drew a right triangle and you wanted to indicate that one of the angles is 90, what do we draw? Ada? We do. We draw a little square in the corner, which is what this is. All right, so there's my right triangle. All right, then they tell us that this is 4.5 centimeters, this is 7.5 centimeters, and this is 6 centimeters. Okay, if these are similar triangles, what do I know about the ratios of the corresponding sides? If they are similar triangles, what do I know about the ratios of the corresponding sides? Amanda? They're all going to be the same. They're equal. So since we are stating that these are similar triangles, I'm going to put a little note here. Since the triangles are similar triangles, we're not proving that they're similar triangles. We already know that they are similar triangles. Since they are similar triangles, the ratios of the corresponding sides are equal. We know that. Okay, so for number 4 it says find the ratio of the lengths of the corresponding sides. So I just want to know what is that ratio. Okay, so if I take a look at my corresponding sides, to answer this question, do I need to find all the ratios? Do I need to write all the ratios if I know that all the ratios are equal to each other, and all I'm looking to do is find out what that ratio is? Do I need to write all of the ratios? Sophia? No, I don't need to write all the ratios, because I already know that they are equal. If I said to you, here are 2 triangles, prove that they are similar triangles, then you would have to write a ratio of all of the corresponding sides, and you would need to see, are they equal to each other? God bless you. But that's not what this is asking. I already know that they are equal to each other. I just want to know, what is the ratio? All right, so I only need to write one ratio of corresponding sides. Why am I super happy about that? When I look at this triangle, why am I super happy that I really only need to write one of them? Valentina? Yeah, I mean, I've got decimals here. If I was to write the ratio, well, first of all, BC and EF are corresponding sides. So if I was to write that ratio of 4.5, here is my FE, over BC, which is 3, that's funky. Right? That's funky. All right, and they want to write it, it's the other way, because they want it the other way. Because they want the ratios of, so we want our ratio of triangle ABC to triangle DEF, so I need to make sure I write that right. If I use my FE over BC, this is going to be, oopsie, other way, BC over FE. This is going to end up being 3 over 4.5. That's ugly. I can't have a decimal in my fraction. All right, so I don't want to use that one. So which set of sides would it be super easy to come up with a ratio for because there's no decimals? What set of corresponding sides? Addie? Yeah, this one right here. We know those two are both integers. So make it easy on yourself. We're not looking to see, are these similar triangles? So we need to see, are all the ratios equal? We already know that they are equal because they are similar. All right, so from here, all I need to write is my AB over my DE, which is 4 over 6, which simplifies to 2/3. So I need you guys thinking about what you actually have to do. Since these were already similar, I just need to figure out the ratio using one set of corresponding sides. Addison, does that help you? Awesome. Amanda, Sarah. Yep. Excellent. You added all the sides together. Yeah. What do you mean you added all the sides together? Why? Okay, so but why are you doing that? Okay, why does that work? So this is what she did. So she said she added, so she did AB plus BC plus AC, and she put that over FE plus FD plus ED. Is this what you're telling me you did? Okay, so you did 4 plus 5 plus 3, and you put that over 4.5 plus 7.5 plus 6. And if you added all this together, this would end up, what did you get for your sums for both of those? 12/18ths, and this simplifies to 2/3. Why? What did she actually find the ratios of? What did you actually find the ratios of? Ada? You found the ratios of the perimeter. Okay, why would the ratios of the perimeter of this be the same thing as the ratios of corresponding sides? Why do you think? I want you guys just thinking. There might not be an exact answer I'm looking for. There's not really an exact answer, but I want you guys thinking. Why does it make sense that the ratios, so what she did is she did the perimeter of ABCD over the perimeter of DEF. Why does it make sense that the ratios of the perimeters is the same thing as the ratios of the corresponding sides? Alex? Yeah, I mean, it's the length of a side, right? How many of you guys agree that the perimeter is just all the sides laying down, like flattened it, and that's now the length of just the flattened sides? How many of you guys agree with that? So if those are similar triangles, the perimeters would be the same ratio, okay? Now, what made you think to do that? Okay. Excellent. All right. How many of you found all the ratios? Okay. So if I was to write them, all the ratios would be, it would be 5 over 7.5, it would be 3 over 4.5, and it would be 4 over 6. How many of you guys got those for your ratios? All right, all of these have to be equal to each other. So for all of those to be equal to each other, we would need to have a common denominator. So for us to make a common denominator here, we'd have to figure out what the denominator would be. All right, how many of you guys did come up with 2/3, but starting with those? What did you do? So you did that for this one. What'd you do for this one? And you got 2/3. So you guys, how many of you guys thought they were asking you to prove that the ratios are the same? How many of you guys thought that's what they were telling you to do? Okay, so let's read this. What does this right here mean? Eyes on the board. Danny, you're paying attention to what I'm saying. What does this say? AJ? That says they're similar. So why do you think this is asking for you to prove that they are equal? Ada? Yeah, it's just asking you, what is the ratio? If these are similar to each other, what is the ratio? That's all that's saying. So make sure that you're reading what to do, okay? If this said proof, like number, number 20, oh, we didn't do 22 yet. We didn't do 20 yet. So today we're going to talk about how we prove that they are. Okay, we're going to talk a little bit more about that today. All right, but for us to prove that they are similar, that's when we have to look at all the ratios to see, are all the ratios the same. Can you guys understand the difference between those two? So you need to pay attention to what is it they are asking for us to do. Okay? All right, put this away, get your notes out. All right, get your homework assignment notebooks out. I'm going to change something here. All right, so your homework tonight is page 303. I want you doing 13 through 20. Uh, 13 through 21. So you're doing 13 through 21. All right, you guys go with that? So put that aside. You're not doing that. You're doing 13 through 21. Why is that? Why should that be a question? No, I said I'm changing your homework. I'm changing your homework. So you're doing page 303, 13 through 21. Okay. So today is 220. All right, we are continuing on with 6.4, so 6.4 continued. All right, we're talking today about similar, but then we're also going to throw into there incongruent figures. And we're going to talk about what the difference between those two things are. Hi, how are you? So today, let's first of all start. I need you guys to get your rulers out if you don't already have them out, please. All right, we're going to start with proving if figures are similar. And then we're going to talk about what congruent means. So that's the first thing we're going to do, is we're going to prove that two figures are congruent or similar. So if you remember from last night's homework, the one that we did, number 4, the given was the two triangles were similar. So we did not need to find all the ratios of the corresponding sides. It just said what is the ratio of the corresponding sides. All right, so what I want to do here is I want to prove that these two shapes are similar. How many of you guys play soccer? Or have ever played soccer? Okay, do you guys notice that you have that goal box, right? You know, the box that's in front of the goal, that if you have a penalty shot, that's when the goalie can grab the ball, is within that goal box. You guys know what I'm talking about? That's what I want you guys to draw. So we're going to draw a soccer field. So use your grid lines. That's why we have graph paper. That's the benefit of it. All right, so find that halfway point. I'm not looking for perfection. It is important that you guys are drawing, however, so you can see it. Visualizing is really important. All right, then what I want you to do is draw the two goal boxes on your paper. So you can kind of use mine as your guide. But again, use those grid lines. It's going to make your drawings a lot easier to look at and a little bit neater. Okay, so here is my soccer field. I'm going to put some dimensions on this. I'm going to get my colors out. Okay, so if I take a look at my soccer field, the soccer field itself is 40 yards wide. All right, my goal box, it is 14 yards by 35 yards. You can kind of see what I mean by those dimensions on mine. All right, and then the whole field is 70 yards long. So here are my dimensions. So make sure you guys have this drawn properly. If you like the colors, you guys can use colors. If you don't, that's cool too. All right, this example is out of your book, so you can always go back to it. All right, so I'm going to write some directions here with the story problem that goes with this. All right, so the soccer field is a rectangle that is 70 yards long by 40 yards wide, so I've already drawn that. The penalty box area of the soccer field is 35 yards long by 14 yards wide. This is what we want to know. Is the penalty area similar to the field? That's what we want to know. Is the large rectangle similar to the small rectangle? Now, if you want to put letters on this to make it easier for you guys to write these ratios, that's fine. So what we have to do is, so if they are equal to each other, if they're similar to each other, what that means is that our ratios of corresponding sides are equal. This is what we are trying to prove. That is what we're trying to prove, because I don't know that they are similar. And if you remember, similar figures means the ratios of corresponding sides are equal. So this is different than last night's homework where they told us the shapes were similar. We just needed to find the ratios. Here we don't know that they're similar. We need to prove that they are. So now we have to write the ratios of each one. Are you guys cool with that? Okay, so instead of me putting the, I'm trying to think what the best way for us to do this is. So I'm actually going to draw arrows between my corresponding sides. Okay? So how about, what would be the corresponding side going with my 40? So think about the orientation of my shapes. What is the corresponding side that goes with my 40? Alex? Excellent. And I'm just going to draw a line to those. Just because I feel like visually it makes it easier to see my corresponding sides. Alright, because if you think about this, if I turn my rectangle, the smaller one, so it's oriented the same way as my bigger one, those two sides light up. How many of you guys see that those are corresponding sides? Are you guys cool with that? Okay. What's my other set of corresponding sides then? Because remember, I need to write ratios for both of them to see if they're equal. What's the other set? Brendan? Excellent. So I'm going to go ahead and draw an arrow on those. Can you guys see why it's really important for you to draw the shapes so you can visualize what we're doing? Awesome. Ada? Okay, that's a good question. So do you see that this is my longer side of my rectangle? Which is my longer side of my rectangle on this one? Yeah. Remember, so corresponding sides are the ones that are in the same location in their same triangles or their same shapes. So if I was to look at this, so I want to use a different set of examples to help you. If I looked at these, can you see that they're definitely like different lengths? Okay. So Ada, if I took a look at DC in this shape, what is the corresponding side with DC in the other shape? Y. They are. Now if I could physically take this small one and rotate it so the orientation is the same. Do you know what I mean by the word orientation? How many of you guys know what I mean by the word orientation? Who's not sure what I mean by the word orientation? Okay, so here's my two rectangles. Matthew, look over here. Can you guys see that they're both going exactly the same direction? So the direction they're going is your orientation. How many of you guys have ever printed on a printer? How many of you guys have ever been like, there's a little thing there that says orientation, and they say portrait, and they say landscape. That's orientation. It's the direction the shapes are facing. So here, this is similar to what we're talking about, Ada. Now, I recognize these are the same shapes, but this is what we're talking about. If I was to draw my two rectangles here separately, this is what they would look like, Ada. One of them would be going this way, the other would be going this way. Can you see that? I mean, I know that they're on top of each other, but this is what it is. For us to find our similar shaped sides, our corresponding sides, we really do need to have them going the same orientation. Does that make sense to you? Okay, so that's why those sides go with each other. Okay, that's an awesome question. So now that I have my corresponding sides, somebody set up my ratios. Once you set the first one up, the other one has to be the same, the lengths from the same shapes in the same locations. All right, so somebody set one of my ratios up. It doesn't matter which one, using your corresponding sides. Cameron? Okay, so I have 14 over 40. Which rectangle, Cameron, did the 14 come from? The small rectangle or the big rectangle? The small rectangle. So that means in my other ratio, the small rectangle has to be in the numerator as well. All right, so somebody write the other ratio for me. Amanda? Excellent. Now, simplify those. Remember, I need to prove that they are the same. All right, so let's simplify those. What common factor do 14 and 40 have? Sophia? 2. So 14 becomes a 7, the 40 becomes a 20. So this is 7/20ths. Somebody tell me, what common factor do 35 and 70 have? AJ? What do you have? What does that simplify to? This is 1/2. So this is 1/2. Is 7/20ths. Now, for us to compare fractions, what do we need to have? Addie? Common denominator. So what common denominator do you want to do to compare these? 20. So let's multiply my 1/2 by 10 over 10, and I end up with 10/20ths. So now these are my fractions that I'm comparing. Are they equal to each other? No. So my ratios are not equal. So what does that tell us about those two shapes? I'm going to say so. What have I now proven? What have I now proven? Remember, this is what goes back to what we were asking. Always go back to the question. Us figuring out and comparing the ratios. What now, since they're not the same, what have I proven? Sarah? Excellent. The penalty box and the field are not similar. That is what I have now proven. You guys cool with that? Yes? Okay, this is one thing I need you guys to do. If you guys remember, I'm always encouraging you guys to learn how to teach yourself something. We have run out of time. We have one example that this is what I want you to do. You are going to take notes. We are definitely going to go over this in class tomorrow. But this is one of those opportunities for you guys to try and teach yourself something. Okay? So, in your assignment notebook, I want you to get it out, and what I want you guys to do is I want you guys to look at example, page number 302, example 4. And I want you to take notes on this before you start your homework, not after. Before you start your homework, because it's going to help you. And then we are going to take notes on ourselves and go over your homework. So this is going to be on page 302. This is going to be example number 4. Remember, I'm trying to teach you guys how to take really good notes and be able to explain something to yourself. We are definitely doing this tomorrow with each other, but I want you to try this and have it help you with your homework, and then we'll go over it more tomorrow. Questions? Yeah. Yeah, you can either put it with these notes or you can put it before your homework. I don't care where you put it, whatever makes sense to you. All right, you guys cool? Okay, we're good to go. Evens, hustle out there because we're a few minutes late.